All right, hey guys, welcome in. This is day 4, our last day of equation boot camp. I'm trying to get ready for unit 3 when we get back from our long break after parent-teacher conferences. You're kind of week off here coming up. So we'll go through some examples here and talk about the Mustang way of solving equations. You guys can work through these and then hopefully have a little bit of time at the end of class today, even with the shortened hour, to work on your homework assignment, which is an IXL assignment for today, okay? So we're going to look at, like I said, the Mustang way of solving equations. We're going to look at equations with variables on both sides. So that's something a little bit different than what we've seen these first couple days as we've been working on things. Okay, so when we talk about some of the things that we've thought about and worked through the last couple days, just some things to stand out here and kind of highlight and mention. Even though we've got equations now with variables on both sides of the equation, okay, we're still going to follow our same steps. We're still thinking isolating the variable, inverse operations, combining like terms when we can. When we see parentheses, we want to distribute, okay? And so all of those things kind of roll into one here, just kind of getting progressively more involved, more difficult, if you will, types of equations that we're solving here, all right? So we call this the Mustang way, and here's why we call it that. We've got BCMS, right? So the first thing we're going to do is we're going to begin with parentheses, and we're going to distribute. So remember, that means we are multiplying, right? That is our operation. We multiply whatever's on the outside of the parentheses by everything on the inside. So if we see parentheses, these are our steps, right? We're going to go in order. If we see parentheses, we're going to begin with that. We're going to distribute. We're going to multiply those values, okay? C goes back to what we saw a little bit on Wednesday in class when you guys worked through the video when I was gone, right? This one is to combine like terms on the same side of the equation, right? So we're looking for like terms, which means terms that have the same variable, right, or no variable at all. So if there's x terms we can combine by adding or subtracting, we're going to do that. If there's normal constant numbers, whether they're whole numbers, decimals, fractions, positive, negative, we're going to combine those as well. We're going to do that on the same side of the equal sign, all right? Where we get a little different here, and we work through this, right, is the M step. That's where we're going to move the variable with the smallest coefficient, okay? So that would be the smallest number that is attached to the variable. So if I'm looking at a 2x and a negative 10x, okay, I want to think about the smallest coefficient. That would be the one that's lower in value, and so it would be a 10x, all right? Negative 10 being the coefficient, the number that is in front of the variable, 2 being this coefficient, the number that's in front of the variable. So since this would be the lowest one, that would be the one I move, or the smallest coefficient, right? Okay, and you'll see that in some of the examples we do and some of the practice problems that you do as well in your assignment, all right? And then the last thing is to solve, right? So we're thinking isolate the variable. That's what we've been talking about when we solve. So isolate the variable, and we do that, remember, by our inverse or opposite operations, right? So our inverse operations get us to our solution. Okay, kind of wrap that around there, all right? So again, just a kind of a nice way to remember it, BCMS here for our school, our Mustang way of solving equations. So we're going to think, begin with parentheses, right? If we don't see parentheses, we can skip that step. But if we do, we want to distribute first, multiply. C is our step to combine like terms on the same side of the equal sign, same side of the equation. We're going to combine those like terms. M is a different step because now that we're dealing with variables on both sides of the equation, we want to move those x terms or those y terms or whatever our variable is, we want to move them to the same side, and we do that with the smallest coefficient in mind. So whichever value has the smallest coefficient that's lowest in value, all right? And then the last step is going to be to solve. And we like to solve, just like we've done all of our other equations so far this week, isolate that variable, get it by itself, right? And we do that by doing the inverse operation. So let's take a look at a couple examples here. We'll do these two together first, then give you guys a few to kind of look at on your own, and then try to answer them together, okay? So here's what we're thinking, right? If we're going to use our BCMS way, our Mustang way of solving equations, the first thing that we want to do is we want to begin B with parentheses, right? So in this first equation, we actually do have a parentheses part, and we did this a lot yesterday in class, right? We thought about distributive property. We multiplied whatever's on the outside by whatever's on the inside. So in this case, I'm going to end up with a 3x, because 3 times 1x gives me 3x. And then it's going to be a minus 15 because I have a positive 3 times a minus 5. And so that value gives me 3x minus 15, okay? That's equal to, nothing changes over here because 2x and 4, those aren't like terms. Remember, that's our second step is to look for or combine like terms on the same side of the equal sign. So I'm over here with a 3x, right? And I'm over here with the 2x. And then I've got a minus 15 and a plus 4. So if my C step is to combine like terms, remember we'll go back here really quick. My C step is to combine like terms on the same side of the equal sign. If I look at this equation, I have an x term and a normal number. Those can't combine. Those aren't like terms. I've got an x term and a normal number that I'm adding positive number, right? Those aren't like terms either. So I can't combine those. That's not possible. So I'm actually really just kind of skipping step C because there's no real combining that can happen here. And then M is my new step that we're looking at today, right? It's a little bit different than these other steps that we've done so far. And the reason for that is because we have x terms or variables on both sides, okay? So I'm actually going to move my variable parts first in this case. All right, I'm going to move my variable parts first in this case. So if I look at this, I'm thinking which of these two is the smallest value. And the reason for that is because when I do my inverse operation, I want to try to always have a positive variable value. So between a 3x and a 2x, my lowest value is a 2x. So I'm actually going to subtract that 2x from both sides. I'm going to take it away, okay? And I bring it to its like term on this side, which is my 3x. And so what I'm left with is just x, or 1x. That's what I want. I still have a minus 15 over here, and I still have a plus 4. So I moved my variable term. So now what has to happen is I need to actually move the part without the variable, right? Because I want to end up isolating my x. That's what we've been doing. So this is a 1x. That's a minus 15. So I need to get x by itself. I need to get rid of the minus 15. And I do that by adding, right? That takes it away, which is what we want. We want x by itself. I'm going to add 15 to this side. And I have a positive 4 plus 15. I get 19. That's my answer. Okay? So I solved. I did that last step there by solving. Once I moved my variable term, the S step is to solve. And I do that by inverse operations. There's just one step here to solve. And I get x equals 19. Okay? So this one's a little bit different because we do want to get our variable terms on the same side. So that M step is the one that's a little bit different. And the reason for that is because now we're looking at equations with the variable on both sides. All right? Let's jump into this next one over here and take a look at that really quick. Okay? So when we think about this one, it's written a little bit differently. The 4x is staying the same because there's nothing else on this side right here right now. Right? So let me go back and change that really quick. Make that look a little bit better. There we go. 4x, right? And that's equal to, if you notice on this side, I actually do have some distributed property, right? And that's what I'm going to begin with. The B stands for begin with parentheses or distributed property. So I'm taking a positive 8 times a negative 2x. So that's going to be an x term. Positive times a negative gives me negative. 8 times 2 is 16, so it's a negative 16x. And then I've got an 8 times a positive 5 or a plus 5, so 8 times 5 would give me 40, okay? So once I do that step, now I'm down to this equation. I began with my parentheses, did my distributive property, okay? And so what I'm going to do here then is I'm going to think C means combine like terms on the same side as the equal sign. So I've got a 4x here that's by itself. I've got a negative 16x and a plus 40. There's nothing to combine with the 4x on this side. And then if I look over here, a negative 16x and a plus 40, those are not like terms. This one has an x variable. This one's a constant number without a variable. So I can't combine those. I can't add or subtract values if they're not like terms. So then I move on to the M step. Okay, the M step means to move the variable part, right? Move the variable part. So be very careful when you see this, a 4x and a negative 16x. I want to think about this in terms of coming up with or finding, right, the variable part that's the lowest in value, overall value, and that's the one I want to move. So I have a positive 4 and a negative 16. The one that's the lowest in value, the one that has the least value, is negative 16. It's a bigger number, yes, but that negative makes it lower in value than a positive 4. So I'm going to add 16 to both sides, 16x both sides. And the reason I'm doing that, again, is to get all of my variables on the same side. So that's why we move our variable parts. And we pick that lower or smaller coefficient to do this. So I end up with 20x's over here, and that's equal to, on this side, we leave our constant number of 40. So now I'm just down to one more step here to solve this. This is a multiplication problem, 20x. That's 20 times x. So if I want to get x by itself, undo multiplication, I do my division step, and 40 divided by 20 is going to give me my final answer of x equals 2. Okay, so this again looks a little bit different, and the reason it looks a little bit different is that m step, right? That m step where you move the variable parts to the other side of the equation. All right, so this says now your turn. I'm actually going to do number 3 with you. I'll let you do 4 and 5 on your own, and then kind of come back and look at this. But number 3 here, again, we do not really like fractions, right? But when I see this, and I look at this, okay, I need to realize fractions don't change how we solve this problem. We're still going to think BCMS, so we need to begin with our parentheses. So you'll notice there's actually parentheses on both sides this time, right? So on this side, I have to take 3/4 times an 8x and times a -4 or -4. On this side, I'm taking a 1/2 times 4x and a 1/2 times a -10. Okay, so we're going to still solve the same way. We're still solving the same way, even though we have fractions. That doesn't change our steps here. So the good thing is, again, you can use your calculator as needed on this. All right, and so it might be easy for you to figure out, okay, well, what's 1/2 times 4 and 1/2 times -10? If you can't do that in your head, use your calculator, right? Think about your fraction button. Do your 1/2, okay? When you're answering that here, do your 1/2 times, pull that back up, sorry. 1/2 times, it's not going to let me do that. Oh, it's going to keep doing this. So let me try to actually change that real quick, guys. Sorry. Let me look at this. Oops. A little bit of a... There we go, guys. Sorry about that. Sometimes when I use this keyboard, it doesn't really work there. So 1/2 times 4, that's going to give me 2. Okay, so I'm going to come over here and say, all right, that's 2x. And then a 1/2 times a -10, if I can't think about that, right? If I don't know what that means, I'm going to do my fraction, 1/2. And then times a -10 this time, so a -10. That's going to give me a -5 when I come over here and write this. All right. So there's my first part that I've simplified after I do distributive property. I'm going to have to do the same thing on the other side of the equal sign, or on the other side of the equal sign, only this time 3/4 is the value I'm multiplying. I'm going to take that times 8x, okay, and then times a -4. So if I do 3/4 times 8, let's figure out what that is. That one's definitely tricky. I don't know if I can do that off the top of my head. So let's do ABC, or AB button, sorry. It's ABC on some of your calculators. So 3/4 times 8. It gives me 6. So I'm getting a whole number again. So 6x, which is really nice. And then minus what 3/4 minus or times a -4. So let's do that one. 3/4 in my calculator with my fraction button times a -4. That gives me -3. Okay, so the nice thing about this is once we do our distributive property, we basically get rid of those fraction parts, right? Getting rid of those fraction parts, which is really what we want. We don't want those fractions involved in there. So now my next step is to think about C. We did B, begin with parentheses. Now I'm on to C. So I'm going to combine like terms on the same side of the equal sign. If you look here, right, I've got a -5, 2x, and a -5 on the left-hand side. Those aren't like terms. This is an x term with a variable x. This is just a normal constant number. Can't combine those. This is a 6x, and this is a -3. Those cannot be combined either. Okay, so I can't do anything really with step C, but I can get to the M step and move my variable part. I'm looking at the one with lowest value. So I have a 6x and a 2x. Which one's the lower value, right, between the two? They are both positive, so it's the lowest number here, and that is 2x. So I'm going to subtract that from this side to move it. Okay, over here I take it away from its like term, so 6x minus a 2x. That's how I get rid of it, which is 4x. And then -3, that stays the same. So if I eventually want to get to an answer of x by itself, now I'm down to a two-step equation, right? Remember, this is my 4x, this is my -3. That's supposed to equal -5. So if I want to get x by itself, that's a multiplication step, this is subtraction. I'm actually going to get rid of the constant number, right? The one without the variable first, now that I'm down to this two-step equation. So I'm going to add 3 to both sides. When I do that, I get 4x still left over here is equal to -2, because I have a +5. If I gain 3 back, I'm at -2. And then my last step would be to divide by 4, because this is 4 times x, right? And so I have a -2 divided by a +4, so I could say -2/4 equals x. Or if I really wanted to simplify that, I could say negative 1/2 is equal to x to get my final answer there. So just because we have fractions doesn't mean we can't solve these. We still follow the same answers here, follow the same way to get our answers and go through these problems. All right, pause the video here really quick while you guys got a chance, and then go and try to solve questions 4 and 5 using your BCMS or Mustang way of solving equations. All right, so let's take a look at number 4 and number 5. So hopefully you took a little bit of time here to work through this and answer these. Let me scroll back up here to number 4. All right, just because there's decimals doesn't mean we change how we do this, right? Okay, so I'm actually distributing first, beginning with parentheses. 7 times 7.5x gives me 52.5x, and again, I can type that in my calculator if I'm not for sure what that equals. But I'm distributing that 7 there, and I'm also distributing that 7 to 3.5, positive 3.5, 3.5. So 7 times 3.5 gives me 24.5. Okay, nothing is changing on this side because we aren't doing anything with parentheses yet. All right, and then we're going to get to the C step here next, where we look to see if we can combine like terms on the same side of the equal sign. If I look at the left-hand side after I distribute, and if I look at the right-hand side just the way it's written, there's nothing I can combine. There's an x term and a normal term and an x term. All right, so nothing to do there in the C step for this one. So then I move to the M step. This is the big one that's different today, right, with variables on both sides. So I'm looking at a 52.5x, and I'm looking at a minus 5x or negative 5x. Which one's the lowest in value? Okay, definitely the negative 5x, lower in value than 52.5. So that's the one I'm looking to move. I want to move that to the other side with the other x term. So in order to get rid of a negative 5x, minus 5x, I add it to both sides. Okay, get rid of it over here, add it to both sides. So now I'm left with 57.5x plus the 24.5, and then the only thing that was left on this side is that negative 50.25. Okay, so this step then comes after we move the variable. We also need to move our constant terms. We want to get x by itself, right? So we think about this as almost a two-step equation now, where I've got my x term, I've got my constant term, right? Without the variable, that's what needs to move first. So in order to get rid of a plus 24.5, I'm going to subtract 24.5. Do it on both sides. I've already got a negative 50.25. If I take away another 24.5, 24.5, now I'm left with negative 74 and 75 hundredths. Negative 74 and 0.75. That's equal to the 57.5 times x. That's that multiplication step, remember, right there. So the last step, which happens a lot in these problems, right, is to divide by that coefficient, that number that's with the variable. So I divide negative 74 and 75 hundredths divided by 57 and 5/10. I get my final answer here of x is equal to negative 1 3/10, negative 1.3. Okay, so check to see if you maybe got one of these numbers wrong, did one of your steps wrong as you're working through that. Number 5 is one that we're finally going to think, when we think about BCMS, we're actually going to utilize that C step here on this one. But we always begin with parentheses, right? So there's parentheses on both sides. The tricky part about number 5 is there's this 4x that's out here by itself. So we really don't do anything with that. But then we have the 5 next to the parentheses. So even though it's the second part of this expression over here on this side of the equal sign, this is actually where I start because I'm beginning with parentheses. So I'm going to distribute there. 5 times 7x is a 35x. 5 times a minus 3 is a minus 15. So now I have 4x that comes there. And then from these two, right, I get my 35x. And then from the 5 and the negative 3, I get that negative 15 or minus 15. So I'm done with that after I distribute. Same thing on this side. I'm going to go ahead and distribute. That's the only thing that's left here is 9 times the quantity of x minus 5. So 9 times x gives me my 9x. Got that. And then 9 times a minus 5 is a minus 45. Okay, so I did my B step. The C step this time is one I can use. I can combine like terms on the same side as the equal sign this time, because you'll notice I've got 2 x terms over here and a constant number, and then just 1 x term and 1 constant. So since there's 2 x terms over here, I'm going to combine those, 4x plus 35, and get 39x. So 39x minus 15 is equal to the 9x minus 45. So I've done that step. So now I'm on to M. I want to move the variable, right? Move the variable part with the smaller coefficient. So if I look at 39x and a 9x, they're both positive. One is definitely smaller than, it's this 9x, and I want to move it. right? I want to do the opposite operation, inverse operation. I'm going to take it away. I'm going to subtract since it's a positive, and I'm going to subtract it from its like term over here. So I'm going to take 39x minus 9x, and so I'm left with 30x minus 15 equals the negative 45 that's left on this side. When I get to this step, right, this is that constant number, this is my variable term, so I want to get rid of that part without the variable first. This is down to a two-step right here. When we get to this, right, we see this, it's a two-step equation. Oh, sorry guys. So I'm going to get rid of the minus 15 because I eventually want to get x by itself. So I'm going to add 15 to both sides. This is where you got to be careful. You have a negative 45 plus 15. I still have a negative value. It's a negative 30 when I add those two together. So I'm left with 30 times x, or 30x, is equal to negative 30. In order to get that x by itself, I need to divide by 30 on both sides. That reduces down to 1x. A negative 30 divided by a positive, negative divided by a positive, right, is a negative answer. And 30 divided by 30 gives me 1. Okay? So listen, guys, I know that that was a little bit longer in terms of going through the examples, but I did want to go through 5 of them with you. So should have about 10 minutes here left in class to work on your assignment. It's an IXL assignment, smart score of 80 like we normally do. So make sure you're working on that, trying to get that done over break. If you have questions, reach out. Otherwise, try your best to get this done in class here, and we will see you guys when you get back from your fall break. Thanks.